Okay, great news. Our circular LED display came in from AliExpress all the way from China, got here in spite of all the coronavirus stuff that's going on, and we got it wired up. As you can see, the back of this, I took leads from resistors and wired them like power buses that go through here. And then on the center LED, we tied a wire to D in. D out comes here, goes into D in of the next one. D out from that one goes into D in of this one. D out from here goes to D in and there, and so forth, so that the data is first in here, last out there. And what that means is that the very center LED is the first addressed LED. And what we're running here is the exact same software that we had on the strip in our prior example, except it's been incremented to handle 93 LEDs instead of the 60 that was on the prior strip. And what we can see on here is that for each of the wings, they're wired so that the LED, which is over the pad, is the first LED, and then the additional LEDs are run in clockwise order. What this means is that this is going to be a very difficult display for us to address, because essentially the array that we send to it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It is definitely not X, Y based. It's more like polar coordinates, which is not something that's easy for my mind to handle. We know that for our Fortnite display, we're going to want to display some circles that are moving around here, some lines that go back it up, and trying to create those arrays by hand seems like something that would probably make you go insane. What we're going to do today is demonstrate an application that I created, which allows us to create those arrays on the fly. You can see here I've got a picture that I took from the AliExpress ad. What you can see here is that I've created a virtual version of our display. On this thing are 93 separate buttons. The buttons are created programmatically by a function that you hand the number of buttons in a particular ring and what their radius are. And it arranges them based on the same pattern that's used on the actual hardware. So we can see here's our center one. This will be 1, 2, 3, 4, 5, 6, 7. In order for us to be sure that these are arranged in the same pattern as the hardware, I created the Swirl Button, whose job it is just to light up the LEDs in the order in which they were created. And we can look at that and say, yes, it started with the center, goes to the bottom, and each one is effectively going clockwise. That means that the LEDs are in the same locations as they are on the display from an addressing point of view. I have various colors up here: green, yellow, blue, others. I can put other colors in here as well. I've got a slider down here. This is a quick and dirty app, so not everything's properly labeled. I'll basically be throwing this away after I get what I want. So let's take a look and create a circle. And actually, let's make that guy a bullseye. At this point, we might want to save this, and we'll call it bullseye.c. And if we take a look at that file, we see that what it's done is it's created an array for us with 24-bit numbers corresponding to each color, with those in the proper order. In order for us to use that, we'll go back to MPLab. You can see I've actually loaded some prior files here. We'll say add existing item, add bullseye.c, and let's go into the part of our program that generates, that we saw last time, that generates that. For each of the LEDs now, instead of using the chase LED, I am going to add our bullseye array. And then what we will do is RGB now let's run that, and we get the bullseye on the screen that we designed. We can go in and change it if we want to. Let's add some blue. And we'll save it again. Save it right over the existing bullseye. Say yes. Come in here. Force this to recompile. And now we have blue. So one of the things that I wanted to do was create vertical lines. I added the ability to load and unload. So I created patterns 1 through 9. So you can see this is roughly linear line. So there's 1. Pattern 2 is effectively the next line down. Pattern 3 is the next line down after that. So in my code up here, I have an array, pattern 1 through 9, then 8 back to 2. And actually, and so what we're going to have it do here what we're doing here is walking now through a bunch of different arrays from each of these different patterns in different files. And you can see, yep, I'm off by 1. I had 1 too many in my code here. You can see that we get a nice animation that's made up of a bunch of different frames. You know, we could do another one. Let's create a smiley face. And then we get our smiley face. So this is something that we obviously can use to create the various circles and lines that we need for our Fortnite display. I'm going to wait on that because it's not clear to me whether or not we're going to be using all of the rings or if the lens we get is going to be sized just for this inner ring. It's possible that we'll cut this one off. That's one of the reasons why we started addressing at the center, is we'll just lose this outside 32 LEDs if necessary. So that's about it for this particular project. Next, we're going to start on circuit design. Broadwell Consulting Incorporated provides help developing medical devices with a focus on developing embedded firmware, which is compliant with IEC 62304, ISO 14971, and ISO 13485, as well as remediation assistance for products already in production. For more information, contact John at Broadwell Consulting.